Good day, guys. Let's continue our lecture series from where we stopped. Today we are looking at functions and program structure in C. So let's look at the essence of functions. Why do we need functions in our program? And the essence of functions in C is that they are the cornerstone of the procedural programming. They also empower us to disrupt complex problems into smaller, manageable, and reusable modules that can be used in our code. Let's look at the goals. Let's see, we are going to look at defining and declaring utilizing functions, managing variable scope and left times, and also understanding the argument parsing mechanisms and parameter parsing, so organizing code for clarity and reusability. The building blocks of C program. In C program, it is essentially a collection of functions. One function must be named main, which is the entry point for our programs. Every programming language has its own main functions. So the entry point for C program is the main function. And as we have seen in our previous videos, so function encapsulates specific tasks, promoting modularity, reusability. It enables us to modularize our code, to provide proper structuring of the code, and also to avoid code replications. Complex problems are best solved by dividing them into smaller manageable functions. Also, let's see function definition. Let's look at function. Function provides an actual body of the function. The statement that performs a designated task. Let's see the general syntax of functions. Function is made up of some components. Number one there is the return type. The return type can be our normal type, our primitive type, or the object, maybe user-defined type. For example, you can also have like a type int, just our int main here. You can see here, come to our code here, you can see that we have int main here. Let's create our normal default function here. Let me call this one as P5. So P5. So let me name this as maybe just name by the C. Then we have include stdio.h. Just this our int main. Our int main here is the entry point for our program. So this is the function. This is the return type. This is our return type int main, and this is the name of the functions. This is the main functions. So once we specify a type here that is not void, we have to return that value. If it is double as well, we're going to return the value, and the type of the value we return must match the type here must match the return value in our code. Now let's see. Let me minimize and continue. Then we have what the return type here is in the main function is int. The function name is the main. The parameter, sometimes in our previous videos, we supply some argument passing list in some of our video series. Please, you can check. And also we have for return value here. Return value and return type is not void, because it's not void. As means it's void, we're not going to have return type. We're going to go have return here. So now let's see some syntax components of it. The return type is a type return, e.g. integer, float, void. The function name is unique identifier for the functions, except we are having function overloading to enable us to achieve polymorphisms. So the function names, if you have function name of the same type, but the parameter list must be different. The number of parameter passed here must be different. And the parameter list can be separated by commas. You can take many different types that we want. You can even take user-defined types as well. The function body is enclosed inside is a scope. It's enclosed in from this brace, this opening, and this closed bracket here. That is the function. So everything inside constitutes the function body. Then let's look at how to execute the function. To execute a function, you call or invoke it. You invoke it using its name by calling it. So let's create a default function. For example, if we create a default function called, let me close that one. I have that one opened. Let me have another function here. For example, if I say, okay, int addition, but if you just even float, let me just make it to kind of be float, int addition. So that means float of maybe x, float y. And so we have return what, x plus y. Then we return this. You can also have it in form just by creating another variable float of sum equals what? Equals s plus y. So this you can just return sum. So also the same thing. We have our float value here. The float type of this is also the sum type is float. So we return the value here. So we can also call it here. We invoke it. We invoke it by just print f. Okay, sum. Just person is f. It's f, right? We can now add it. Let's say the addition of %L, for example, any value we added, %F and %F is equals this. Then we can now say, okay, if we have it here, this will float A equal to 90.20.45. Then float B equals 78.33. So then we can easily pass our what? You can say, okay, A, B, then addition, then A, comma B. What do we have here? What am I having here? I'm having here the first placeholder here represent the A. It should display the value of A here. The second placeholder here is what? It's B, which I pass here, and the addition, which is this. This is A and B. So if we now compile this program, we should be able to have our program here. Can you see addition of this and this equal to what? 168 point this. Okay, we've seen the sample of the code we just demonstrated. Let's see now. You can also do the same thing here by running this code. So we get the result as well. So also let's see. You can also do the same thing for void, great, to say hello for someone, hello for user. This does not return anything. You can see that it's not returning anything here. You can also demonstrate it as well. You can also see, okay, let's get user information, for example. Let's just create here void, maybe greeting, say hello, for example. So hello, you can just call, okay, print. Hey, printf means print format. Hello, son, hello, how are you today, son? Then if we call this, you can see that we're not having a return type. If you put a return type here, that will be an issue. Return something, maybe it's a string out, a character, right? Let's return something. You can see it's good to be something. It's good to give us an error, right? It's going to give us an error that we don't have return here. So we don't need any return value here. Understand? Since it's void, the return type here is void. Then we do just, if we call it here, just come it here and just call it here. Let's invoke it here. Say hello. Can you see? Then come and separate it. Let's run it now. Hello, how are you doing today? Addition something, because I don't allow it to come to the new line. This one should be on a separate line. Understand? Hello, how are you doing today? From here, you can just make it to come to a new line by adding the what? By /n means a new line. /t means tab, to give it a tab. Understand? /r means it calls you what? Everything just be on the same page. So just slash n to fall into a new line. This slash n is common in all programming languages, in majority of the programming languages, to break things into a new line. Then we cannot compile it again. Can compile it, can see hello guy, how are you doing today? We can also see we pass a parameter here the other time. You can also just pass the name of that user here. In C, we represent characters in string in form of character, except we want to also import a library called string. Well, let's just use the default one, which is character. Let's call it the name of the string, the name. We don't know the amount of character they want to pass in. Let's just leave it as empty. Then the hello, hello, what is the name of that person? It will include the %s, means what? It should include the name here, right? Let's just put the name here. This is a placeholder. That means this is a placeholder. After this, it will take this and put it inside this. You put it inside this. It's inside the string something. Now it's expecting me to put something here now. Then let me just again hello what? I need to. So now I can run it now. I'll just see expecting what it said. Hello, Lion Newton. How are you doing today? You can see. Can you see? It included the name here already. So now let's continue. You can see you can also put void there without putting anything. So let's see our main function. Just this is the same thing. This is the same thing of what we have demonstrated before. So you can also perform square operations. But let's look at some key benefits of reusability. Sometimes you want to perform addition. We go to addition in many forms. You want to add some several numbers together. We just need to add it, write the code once, and in the next process, we don't need to be writing s plus 2, like for example now, s plus y, we don't need to be writing over and over again. Once we just, only what will be changing is the value that we pass here. We can also cause another value. For example, now if we put this one, if we put the value here, we can also have another print statement here, and just print it out already, and just let me just remove all this and something. Addition is this. Addition equals to this. So just remove this a because we don't have value for this. Then just have a and b. Let's just call it. Let's just give it different value. Maybe 78.23 and 45.21. Understand? If we run this again, we get our results now. That we don't need to write another additional code again. Can you see it's not placed in the new line? Let's place it in the new line so that everything will be separate, will be well listed. Then we run it now. Can you see LEDs well listed and well added? Now we can also let's continue. You can reuse it multiple times. Then function allow you to write logic once. You calculating the square and reuse it multiple times by simply calling it. This minimizes code duplication and enhance readability. Now informing the compiler. Let's look at function prototype. If you observe that I have been putting my code above the main functions, I did not put it down the main function. This is what I mean. If I cut all this function, user could define function, I put it downward there. You tell me that function is not defined. Some compiler will have to be seeing it now, but some of the function I have to put it down here for me to notify the function that there is something on. You have to what? Can you see? It's telling me that what? Error. Implicit declaration of function. Say hello. Function. Say hello days. It's also complaining about those functions. It's not seeing those functions. So there is something called function prototype. The function prototype is to what? Tell the compiler we have some function declared down of the same type and function parameter down. That we have some function type. Look at it and check it. Understand? Let's, for example, now for us to do this one, we have to what? This is what is here is void. For say hello. It started, the return type is void, say hello, the same way, but it's taking a parameter, right? I just leave it here as a car, right? It's taking car array, declaration is incompatible, so car of array, right? Let's just leave it this way. You can also put the name if you want. You can just leave it the same way, but it's array of character. Then can you see my error? I'm using error lens to check for the error, so you can install it from the VS Code plugin. Then for the remaining one is the addition. It's taken into float point, so the following is also float. Just the same way, addition is taking in floats, two floats. So you can also include the names just the same way. Just copy this one and put it upset and put it up there. So this is function prototypes. Enable in case you don't want the time you want to be coming on top of your main function to be declaring it. Then we have then you can now run it. Can you see it's run now? It's not working now. This is the error we have the other time. Now let's continue with our program. Then we have function prototype. Its declaration inform the compiler about function's name, return type, and type of parameter, the parameter list that we pass into it. So let's look at it. You can see, also I've demonstrated with a sample for you. You can also check this code as well and run it. And you can also request for the slide and let me know and send it to you. You can see, or I attach it to the main vStream later for you if you request for the slide. So then you can also see the same way. Advantage of modularity and verifications. Function prototypes enable modular code organization. They allow the compiler to verify that functions call use the correct number and types of arguments. What do they mean by that? Let's come back to our code. This is what they mean. In our code, there's difference between parameter and arguments. Once we declare, let me clear this error. I'm not like it. We see. See, when we declare a function here like this, we give you what these are called parameters here. This can name is parameter. You can have other names on it. Age. You can see have another one int age. Understand? Then you can give it another age of this. Maybe your age is this age. Understand? Then you can have age. How are you? You are this hold. Understand? Then you can put this and supply it here. But here is still expecting me to put one more character, which is what? Int. Understand? And here again is expecting maybe you int age. For example, int. Our age cannot be negative. Let's make it what? Unsigned. Unsigned int age equals to what? Maybe you are 12 years old. So then therefore we put our what? Our age here. But mind you, it's unsigned. We are passing in sign to it. Let's also make it unsigned. Then we have our age here. You can also unsigned. So I think we are clear now. So then we have our age. You have 12 years what? You have 12 years old. So let's run it back. Can you see that 12 years old? So that is the this is now called argument now. By the time you are declaring the function, it's called the parameter. Here is called the parameter. Here is called the parameter. By the time you are now invoking it or calling it, you now pass something inside it. You pass some data inside it. It's called an argument. So you pass an argument into the functions. Then now let's move on. Value 2, you can pass. You can read all these values. You can read them. You can read them. You can read them. So copies of the values. So you can see we have a void try modify the values. So you can modify the values and you can test them. If you have any issue, you can let me know about this code I'm having here. Just the same thing as what I'm also practicing for you guys. What is the significance of passing by value? Passing by value protect data in the calling function from unintended modification by the called functions. So it did not modify, there's not any modification in the called functions. To modify original variables, pointer, we have to use pointer and by reference emulation. So you have to, but you're still going to get a pointer and require for, and it's advanced topic. We're going to see that in the future. So let's send the data back. Function can send a single value back to the calling code using the return statement. If we also want to return more than one single value, just as we have seen here or in our code here, we just return only one value here. In case you want to return multiple value, we can also use a custom type or other type, something we can use in the future. Other method approach. A function declare void cannot return a value, as you have seen. However, return without a value can be used in void function. Is it clearly? So you can see here, you can see number 1 plus number 2. If this returns S, return false. You can see our code. Return values are the primary mechanism for functions to provide results or status information to their callers. This allows functions to compute value like add or report condition like is positive and influence program flow. Rules. Let's look at some scopes of rules. Some scope. So anything inside our block, our open and close braces. We are talking about this. What are they saying here? Here, right? For example, here, opening braces here and close braces here. So all this, the sum here, I declare here, I cannot use it outside. I cannot use it outside. For example, now, I cannot call sum here. Just look at my IntelliSense. Can you see there's no somewhere? But if I declare something, if I make it global, I declare something as integer and I make it float sum, maybe equal to 0, for example. I declare sum as variable. Can you see? It's expecting to do, and it's good to see sum here. Can you see? I'm able to see it here in my IntelliSense variable, and I will be able to use it. Now I can also remove this. Can you see sum equal to this? I can also still compile it, and I still be able to get my result back. This is global variable. But if I declare it inside here, I won't be able to use it outside of the functions. Now, therefore, let's continue from the scope. The scope determines the region of program where a variable or function identifier is visible and can be accessed. In essence, it dictates where variables and functions are known and usable within the programs. Variables declared inside a function or a block are called local variables. So they are local variables. That some inside is called a local, but some I declare outside is called a global variable. Scope, and whatever I call the variable, the functions, that some terminates. It cannot go beyond that. Accessible only within the functions or block of the definition, not visible outside. The lifetime scope, the lifetime, are the storage durations. Then when does the lifespan of this sum, where is it? This sum now, if I make it float sum. So if I make it, I have two sum now. It's going to make use of this one inside before. If we don't see anything like that, it will look for one. Is there anyone declare outside? So the lifespan of this sum ends after the end of this function addition is called. So therefore, you can also read memory allocated upon entering the block. Memory is deallocated upon exiting the block. Values are generally lost between functions call unless declared static, which alters storage duration but not the scope. Understand? So this advanced, we talk about static, but this advanced topic we still talk about them. But you can also see you have a void. This is local variable. Automatically we have int. This is local variable 10, as you have seen, like sum. This is under function int local variable. Understand? So local variable automatic storage location. So int main local, you can see main local variable. Don't mind the latex. I use latex, so they are combined together. So you can see, you can check the benefit of local variable. Local variable limit naming conflicts and prevent unintended modifications. They foster self-contained functions where internal variable don't interfere with other program parts. We talk about global variable, the static storage durations, like the sum I declare up there. Understand? So global variable is global to all the functions. All the functions can access it. Even the main function can access it. Understand? So this variable declared outside of any function are called global variables. scope, potentially accessible from any functions defined after the global variables. The lifetime, how static durations, memory allocation, program start, memory remain allocated until program terminates. So the program is, even after all these functions have been called and still used, it still retain the value stored. But the end of that program, what is when time I exit from that program, I terminate from the terminal, the program's ends. Let's see, overuse is generally discouraged because it reduces modularities and functions. It becomes dependent. Increased tracking modification to global variable can be difficult. Naming conflict, higher chance of name collision. Sometimes you are having this, you may have some kind of collisions which does not match, or which does can create a conflict between your code, in which you even know which one you are using inside the local and which one you are using in the global variables. So in global count, you can see, for example, we have a global counter here because it's global to the other functions. You can see, just as I've demonstrated for you as well. So until the program terminates, before the variables there was terminate. Let's use appropriate use of global variables now. Global variables can be suitable for data genuinely needed across multiple functions throughout the program lifetime. E.g., configuration of settings share in hardware status. So I think let's drop the curtain close here. Let's stop here. So please love it, share, subscribe, and I will see you in the next tutorial. So I'm going to solve a sample of these functions with some complex example using functions in the future videos. Thank you very much. Have a nice day.